Hi everybody, this is Eduardo Suarez. Today we're going to continue with iRVision 2D. On my previous videos I showed you how to configure 2D single view vision processes. We used a GPM, geometric pattern match, to teach a reference part, and then we used the vision process to find the offset of a single part. Today we're going to do two different things. We're going to use the same GPM to find the offset of several parts of the same kind. And we're going to group the parts as a model ID. And then we're going to create another GPM to train a different part. And we're going to group this second part with another model ID. You're going to see that the process is going to be very similar to what we have done before, with a little tweak on the vision process configuration and also on the TP program. We're going to start with one of the work cells we used on one of my previous videos, and we're going to rename it. We're going to call it single view 2D multiple parts. We're going to make a couple of more changes. We're going to select the camera, and we're going to change the focal length to 8 millimeters. So this way the field of view is going to be bigger. And the other thing that we're going to do, we're going to select the part. We're going to call it Model ID 1, and we're going to change the scale to make it a little smaller. Now, since we have changed the focal distance for the camera, we need to do the camera calibration again. So we're going to select the table, and we're going to bring the calibration grid. We're going to open the teach pendant, and we're going to make sure that we are in the position register number 2. That's going to be the calibration position 1. We're going to press Shift, move 2, and we are in that position. Now we're going to select robot. We're going to select Internet Explorer. We're going to go to iRVision, Vision Setup, and we're going to do the camera configuration again. We're going to press Snap, and over here we are not going to make any changes. We're going to go to Calibration Setup. We're not going to make any changes either. Calibration grid location. We're going to press Set. We're going to select calibration. The number of planes is going to be 2. So now we are in the calibration position 1. We're going to make a snap, and we're going to find the first plane. We're going to move the control points to enclose the dots on the window. And the calibration data was recalculated. Now we're going to move the robot to the new position. It's going to be the position register number 3, calibration position 2. And we're going to repeat the same process with the second plane. We're going to take another snap, and we're going to find the second plane. The calibration data was recalculated. We're going to press OK. And now we can look at the calibration points. We want to have the plane number 1, and you can see that it's a small difference in here. You cannot really see on the screen, but there is a red cross mark where the data is supposed to be and where the data is located. And this will be for the plane number 2. You want to see that there's a small error on these points on the area over here and over here too. Not a big deal, we're going to leave it that way. We're going to save and we're going to end the edit. So now we finish with the camera calibration. We can remove the calibration grid from the table and bring back the part. We're going to select the table. We're going to move the robot back to the position register number 2. We're going to select the table and we're going to make the calibration grid invisible. And we're going to make the part visible. So what we're going to do now, we're going to select the vision process. We're going to edit. And we're going to do the edit it again for the part because we changed the size of the part. So we're going to select again the parent tool for the vision process. We are not going to make any changes over here. We're going to select the snap tool, and the snap window, we can take a snap and we can select all the area for the field of view of the camera. What we're going to do, we're going to start moving the part all around because we're going to have many parts. So we need to extend the area for the snap window. We're going to press OK. And now we're going to go to the GPM locator tool and we're going to retouch the part. So we're going to press stitch. We're going to press OK. And a couple of things that we're going to do. We're going to set the origin. We're going to move the origin on this point over here. And we're going to train the mask. We're going to edit the mask. I know already that we're going to have some issues over here on this area and on this area. So we're going to mask that area. We're going to do the same over here. And we are done. You're going to see here that on the model ID, we're going to select model ID number 1. And we're going to change the elasticity. Probably we're going to give it a little more, 3 pixels. We're going to set the search window. Our search window is going to be all the field of view. And for now, we're not going to make any more changes. We're going to go to Set Data Calculation Tool. And over here, we're going to change the part Z height. We need to know what is the new height that we have. So we're going to go back to the part. We're going to zoom in. And we have almost 17 millimeters. So this is going to be 17. And now we're going to set the reference position. And this is going to be our reference position. And this is the position data. We're going to save. And for now, if we go back to single view vision process, you're going to see that the number of parts to find is going to be 1. And we're going to change this one to 10 parts. And we're going to save. Now we're going to go back to the work cell. Something that I want to mention is that the error that we saw on the camera calibration is due to two things. One is the fish eye effect of the shorter focal length on the camera, and the other one is because we're using a calibration grid that is smaller than the field of view of the camera. Now we're going to open the Teach pendant, and we want to make sure that our TP program still works. We're going to press Select. We're going to select our program, and we're going to change the coordinates to the user frame number 1. And we're going to retouch our position. We're going to press Shift Touch Up. And when it says subtract vision register number 1 from the current position, we're going to select yes. We're ready to run our program. We're going to go in step mode. We're going to go to Home. We're going to go to Calibration Position 1 and take a picture. We're going to get the offset. We're changing the user frame. We're going to be in the approach position. And then we do a touch up. We're going to run it again. So far we haven't done anything new. What are we going to do now? We are going to select the table and add more parts to the table. Here I have my parts. I added 4 more parts. So now what we want to make sure, we're going to go to the position register number 2 and make sure that we can see them on the field of view. We're going to select the vision process. We're going to take a snap. We can see all the parts. Over here we have the number of parts to find. It's going to be 10. So now we're going to take a snap and find. And we were able to find all the parts. You can see here, this is the result. We're going to have an index from 1 to 5. And you can see the position for X, Y, the rotation. This is going to be the model ID and the score. And you can sort it, the result. In this case, we are sorting by score, but you can change the sorting data. You can go by row, column, angle, scale, etc. We're going to keep it that way. You probably cannot see there, but there is an index. So this is going to be number 1. Next one is going to be number 2, number 3, number 4, and number 5. So now what we need to do, we need to change our TP program to be able to pick up all the parts instead of just picking the reference part. We're going to go back to our TP program, and what we're going to do is very simple. We're going to select this line over here, and we're going to add some lines. So after we do the vision run find for the vision process, on the next line, we're going to go to instructions. We're going to select vision, and we're going to look for get number found. And what this is doing is gonna give us the number of parts that it found. Next thing we're gonna do, we're gonna put a for loop. We're gonna select a register number 2, and we're gonna go from 1 to register number 1. So we're gonna do a loop for all the parts that they were found, and then we're gonna get the vision offset, and we're gonna offset the position. Over here, what we want to do, we're going to end the loop, and we are ready to try again. We're going to run the program, and we're going to see what happens. It's taking the reference part with an offset 0. It's going to the next part. And just keep going through all the rest of the parts. When you look at the program, you're going to notice something interesting in here. You're going to see that on line number 10, we do the vision run find only one time. And then based on that, it knows how many parts that we have. And the only thing that we need to do is loop the vision get offset. So the change that we did in the program was very simple, just adding the get number found and do the for loop. So this is done. What we're going to do now, we're going to introduce a different part. We're going to create a new model ID, and we're going to teach the reference position for that model ID. And we're going to do the same process of adding more parts and finding at the end all the parts with the program. Here I added a new part type. I'm going to call it model ID 2. Now we're going to go to the vision process, and we need to create a new GPM locator tool. We're going to select the parent tool. We're going to press on add, and we're going to add a GPM locator tool. Notice that the GPM is going to be a child from the parent tool. We're going to take a new picture, and now we need to make sure that we are on the position register number 2. We're going to take a snap. We found the part. Now what we're going to do, we need to train the part. We're going to select the GPM locator tool. We're going to select teach, and we're going to select this part over here. We're going to set the origin. The origin is going to be over here. And we're going to train the training mask. I know again that I'm going to have some issues over here. We're going to mask it out. And we're going to do the same with these other parts in here. We're going to change the model ID. We're going to select number 2. And we're going to change the elasticity to 3 pixels. We're going to look at the search window, and we're going to select all the field of view. Now we can go to the offset data calculator, and for the reference data to use, we're going to change from static to model ID. And you're going to see here that we have already one index number 1, that is going to be the model ID number 1. We are going to press in here on add, and we're going to add a second index, and we're going to select the model ID number 2. We're going to select the part Z high. I already know that's going to be 8 millimeters. And now what we need to do, we need to set the reference position status. We're going to press set, and we're going to use this part in here. And we're going to press OK. So you can see now that if we do a snap and find, we're going to find all the parts for the model ID number 1 and the parts for the model ID number 2. Now we can press save, and now we can go back to the work cell. We're going to select the table again, and we are going to add more parts. Here I added more parts, so in total we're going to have 10 parts between the model ID number 1 and the model ID number 2. We're going to go back to the vision process, and we're gonna do a snap and find. And you can see here that we have some issues on this part that we are not gonna be able to find them. So we need to fix that. We're gonna select the GPM locator tool number 2, and we need to do some adjustments. We're gonna go to the training mask, and we're gonna mask a little more the shape of the part, and we're gonna see what happened now. We do a snap and find, and we can find the part number 4, and still we have issues over here. So we're gonna change the contrast ratio, and we're gonna lower it down, and we're gonna try again, and now you can find all the parts. You can see the issue was the contrast ratio here is a little lower than 50. Okay, we're gonna save, and we can go back to the work cell, and we can look at the program again. In this case, I have created a new TP program line to save some time and make the video shorter. We're gonna have the main program, we're gonna have the peak model ID 1, and we're gonna have the peak model ID 2. We're gonna look at the main program. In this case, everything remains the same up to this point. When we get the vision run find and the vision get number found, and then we're gonna do the for loop. You're gonna see here that I have this part, this is commented out for the moment. This is where we're gonna be calling the peak model ID 1 and model ID 2. We're gonna look at that for now. And we're gonna run this program. Okay, the program was executed. And what we're gonna do, we're gonna look at the line number 16, where inside the for loop, we are getting the vision get offset, and what we're putting that on a vision register that is indexed by the for loop. We're gonna go to data, we're gonna go to vision registers, and you're gonna see here that we have 10 vision registers, one for each one of the parts. If we go to details, you're gonna see here a few things. We're gonna have the model ID. So for the first part that you found, the model ID is number 2, and we have the found positioning here. We can compare this result with the one that we have if we go back to the vision process. We do then snap and find, and something that you're gonna notice that is they are not gonna be on the same order probably. So this part is the model ID number 2, and the found position is 228 millimeters, so it's gonna be this part over here. Next one, if we go back, we can select the vision register number 2, and again is the model ID number 2, and the found position is 491. That's going to be the part number 2. And you just can keep going looking at all the vision register. The important thing here that we're going to have the model ID for each one of the parts. If we look at one of the latest one, the last one, you're going to see this is the model ID number 1, and the found position is 413. That will be the index number 9 that we have in here. So next thing that we're going to do, we know already that how can we get the model ID, and we're going to use this one on the next instruction. So I'm going to come to this part of the program, and I'm going to remove the remark. And what we're going to be doing here is using a new instruction that's going to get the model ID from the vision register, and we're going to put it in a register. The way that you do that, if you look at the instructions, you're going to see on the vision, there is an instruction that is called vision register model ID. So when you use this instruction, you're going to come up with this line in here that's going to ask you for the register when you want to put that. So we're going to select register number 3. And for the vision register, we are going to use indirect addresses. And we're going to use the register number 2. That's the index from the for loop. So that now, once we have the model ID, we're going to use a select instruction. And we're going to call the pick model ID number 1 if we have the model ID 1. And if the register number 3 is the model ID 2, we're going to call the pick model ID 2. It's very simple. If we look at the pick model ID 1, for example, you're going to see that the program is very short. The only thing that we're doing is just selecting the new user frame and doing the same process again, going to the approach position, the pick position, and we go back to the approach position again, always using the vision offset from the vision register, in this case using the indirect addressing from the for loop on the register number 2. And then I'm using the simulation program from picking up the part and then for dropping the part. Before we can run the program, we need to touch up the reference positions. We're going to select the user frame number 1. We're going to go to the pick model ID number 1. We're going to touch it up. And we're going to do the same for the model ID number 2. Okay, so now we are ready to run the program. I'm going to run the program, and I'm going to fast forward the video because this is going to go very slow. You can see that the program ran very well. It was able to identify the model ID 1 and the model ID 2 and get the offset for each one of the model IDs for each one of the parts. You're going to see that there is another way we can do the same. If we go to the vision process, here we're using only one vision process with two GPMs, locator tools. There is another way we can do the same, is that instead of using one vision process, creating two vision processes for each one of the model IDs. That probably would be a more advantageous way to do that if you know that you want to run only one model one time, and then you want to run another model ID another time, or you have multiple model IDs. That would be more easy for troubleshooting. In that case, what you want to do, you want to create a program that you call only the vision process that you want to run. In conclusion, adding multiple parts to the vision process doesn't really add more complexity to the vision system. You can see in the program that the only thing that we did, we added two more instructions. One instruction is going to give us the number of part founds, and in the case of multiple model IDs, we use another instruction that's going to give us the model ID from the vision register that has the offset for the part. We can either use a vision process that has multiple model IDs, or we can create separate vision processes and handle the model ID independently by calling each one of the vision processes from the TP program. I'm going to leave the link to the work cell in the description below, and thank you for watching.